ठीक है, two particles P and Q of masses, two particles P and Q of masses. All right. Acha, sorry, I just forgot you people to tell the paper. So we are solving Feb March 2021, paper 42, M1. Okay. So the first question: two particles P and Q of masses 0.2, 0.3 respectively are free to move in a horizontal straight line on a smooth horizontal plane. P is projected towards Q with 0.5 meter per second. At the same instant, Q is projected towards P with speed of 1 meter per second. Okay, so we have P and Q. Okay. All right, so this is like this is P. All right, and this is Q, and this is like 0.2 kilograms. All right, we use a 0.2 kilograms. This 0.3 kilograms. All right, and this is projected towards Q, and Q is projected towards P. All right, and 0.5 meter per second. And this is 1 meter per second. So these are the speeds. These are the speeds before collision. And after collision, Q comes to rest. All right, 0. While after collision, what will the speed of P is unknown, x meter per second. All right, after collision. Now we are supposed to find out the speed of P after collision. So we're going to be applying law of conservation momentum. That says M1 U1 plus M2 U2 equals to Mustafa M1 V1 plus M2 V2. All right. Mustafa, we need to set the sign convention as well because momentum is a vector quantity. So I'll be taking right as positive, left as negative. All right, and vice versa. You may take the other way. It's your choice. Now M1 is going to be of P times U1, which is going to be positive because it's towards right, plus M2 is of Q 0.3 times, it's going to be -1, the speed of Q, because it's directed towards left, equals to M1, that is 0.2 times V1, the final velocity of P is unknown, plus M2 0.3 times 0. Because after collision, Q has come to rest. So it's going to be what? How much? It's going to be how much? Umar, do you have the calculator? Wait, let me get the calculator. Yes. So 0.2 into 0.5. It's going to be 0.1 minus 0.3 equals to 0.2 V1. Yeah. So it's going to be minus 0.2 equal to 0.2 V1. So V1 is going to be equal to minus 0.1 meter per second. That means it would be V1 as equal to 0.1 meter per second. All right. Mustafa, now there's one thing that you need to understand, and Umar Irfan, you as well. Although we got V1 as minus 0.1 meter per second, and what does minus tells you that after collision, the velocity of P is going to be towards towards left. That is, after collision with P, after collision with Q, P is going to be moving towards left. That's what this minus sign tells you. All right, because we have taken negative as we have taken negative as directing we have the negative sign representing the direction towards left. So I'm getting the velocity of P. I'm getting velocity of P after collision is negative 0.1 meter per second. That tells that after collision with Q, P is going to be moving towards left. All right. But because the question asks you to state the speed, so that means you don't need to include this negative sign, because this is denoting the direction. And we are not asked to state the velocity of P after collision. We are asked to state the speed of P after the collision. So I have written it down in the next step, and I've just removed this negative sign. I've just write down the magnitude, which is 0 and 0.1 meter per second. Is it clear or not, both of you?
Yes, sir.
Yes, sir.
All right. A car of mass 1400 kilogram at constant speed traveling up a straight hill. Okay. Mustafa, I'm just representing car with a box. All right, and it is traveling at constant speed. Now that is again, what does constant speed means? Constant speed means no acceleration. No acceleration means no resultant force. All right, so constant speed. All right, and the hill is inclined at degree alpha. All right, and okay, it has a mass of 1400 kilograms. It's going to have the force of gravity. All right, that's going to be mg. And let me resolve mg into two components. That is going to be, because we now this is an inclined plane, this is an inclined surface, so we're going to be resolving the this force of gravity into the components that are parallel to the plane and perpendicular to the plane. All right, now if you look at this mg is always directed vertically downwards, but because the plane is inclined, so what I'm going to do is that I'm going to be resolving this mg into components that are parallel to the plane and perpendicular to the plane, like this. So this is a component parallel to the plane, and this is a component perpendicular to the plane. All right, and this is going to be alpha as well. Now, how this is alpha? Whatever the angle, whatever angle at which the hill is inclined, whatever angle at which the hill is inclined, we have the same angle that forms over here. And this is as per mathematics. I'm not getting into that detail at this point because we don't have that much time. Not getting in at this time that how come we have these two angles that are same. You just the theory behind this is very simple, that it's just what you have already learned, all right, in GCSE mathematics related to the angle between parallel lines. So this angle, the angle at which the hill is inclined, and this angle, these are the same. So, and this component that is perpendicular to the plane is going to be directed downwards, and this component parallel to the plane is going to be directed down the plane. And this component is like adjacent to the theta, adjacent to alpha. So this is going to be cosine component, mg cos alpha. All right. And Mustafa, this component is going to be opposite to the alpha. So this component is going to be mg sine alpha. All right. Now, what else? And we have been given the value of sine alpha. So we're just going to put up in the equation, not right now. Okay, and there's a constant resistant force of magnitude. Okay, basically, the car is traveling up the hill, so the resistive force is going to be directed down the plane, down the hill. So I'm just going to take this as force of friction. All right, and this is 600 newtons. The power of the engine. All right, this is the power of the engine. The power of the engine is going to be in the direction, you know, of course, there must be some force. There must be some force. There's the force of engine. All right. If you have been given power of engine, that means there must be some force the engine must be exerting. All right. Remember, if you have been given the power of the engine, there must be some force the engine must be there must be some force the engine is exerting. All right. So I've marked this force directed up the hill, and I have labeled it as Fe. That is the force of the engine. All right. Now I'm gonna apply. I'm gonna apply what? I'm gonna apply Newton's second law. All right, and also yes, there's a normal reaction force like this. The normal reaction force is always remember the normal reaction force is always directed at right angles to the surface. All right, away from the surface, and the normal reaction force uh, is directed away from the surface and at right angles to the surface. So if the first surface is vertical, then the normal reaction would be like horizontal, like this, away from the surface. If the surface is horizontal, so it's going to be like this. But remember, for a normal reaction force to exist or to occur, the object must be in contact with the surface. All right. So for an object that is falling in the air, it is in contact with any solid surface. So yeah, there won't be any normal reaction force. All right. And if the surface is inclined, so the normal reaction force, if it exists, it's going to be like this, perpendicular to the surface. All right. So I've drawn it perpendicular to the surface. Now I'm going to apply Newton's second law. I'm going to apply Newton's second law, Mustafa, along the parallel to the plane, not perpendicular to the plane. All right. I'm going to be applying. I'm going to be applying Newton's second law parallel to the plane, and I'm taking up the plane as positive. I'm taking down the plane as negative. All right. So I'm going to take Fe as positive plus I'm going to take force of friction as negative equals to M is 1400 times 0. A is 0 because it is traveling at constant speed. Now Fe I don't know, minus 600 equals to 0. So the force of engine is going to be equal to 600 Newton. And I know that how do you calculate the power? How do you calculate the power? That is the force of the engine times the average velocity, your average speed. All right, that is, yeah, average velocity. So that's how you calculate power. So we have been given power that is 22,500 equals to 600. No, we have another force as well. Sorry, my mistake. I just forgot one force over here. That is, if you look at this, Mustafa and Mustafa Khaja and Umar Irfan. If you look at this now, this is also a force. This is one component. This is one component of the force of gravity that is also acting parallel to the plane or parallel to the hill. So, and this is like acting down the plane. So I'm going to take that as negative as well. Minus mg sine alpha, or that equals to 0 basically. Because why 0? Because 1400 times 0 would be 0 because the acceleration is 0. Let me write it down, 1400 times 0. So this is going to be minus 600 and it's going to be minus 1400 into 10 into 0.1. We've been given the value of sine alpha is 0.1. Okay. 1400 into 10 is 0.1 equals to 0. So Fe is going to be equal to what? 1400 into 10 into 0.1. It's going to be 1400. It's going to be plus 600. It's going to be 2000. Fe is going to be equal to 2000. 2000 Newton. And now we know that power is basically force times average velocity. So power is 22,500 watts. That is what it is. Yeah, 22,500 watts equals to 2000 times V. So V is going to be equal to what? 22,500 divided by 2000. Going to be 11.25 meters per second. Is it clear to both of you or not?
Yes, sir.
Umar Irfan, is it clear?
Yes, sir, clear.
The car moving with a speed 11.25 meter per second comes to a section of the hill which is inclined at 2 degrees to the horizontal. Given that power and resistance force do not change, find the initial acceleration of the car up this section of the hill. Now, they are saying that the car moving with a speed now there's like, I'm drawing only this section of the hill. Now, basically, you can say that it is like this. If you take sine inverse, sine inverse 0.1, so sine inverse 0.1 gives you 5. That means the angle is around 6 degrees. Now, as you move along the hill, you will reach a point beyond which this inclination reduces to from 6 degrees to 2 degrees. All right. So let me show it to you how it's going to look like this. No. Like this. So it's going to be like this. It's going to be 2 degrees. All right. And at this point, again, okay, the initial velocity is how much? 11.25 meter per second. All right. Just as the car entered this section of hill, the speed was 11.25 meters per second. And at this point, what was the acceleration? That's what we are supposed to find. And this says that the power and resistance force do not change. The power remains the same. Find the initial acceleration of the car. Now, what is going to vary? What is going to vary? I'm going to let me draw. This is going to be mg. And let me draw the components. Like this. You have 2 degrees. And like this. So this is mg cos 2 degrees. This is mg sine 2 degrees. All right. And this is again the normal reaction. All right, and now I'm gonna apply Newton's second law again. Okay, this is the engine force. This is the engine force, and this is the force of friction. All right, I'm gonna apply Newton's second law again. parallel to the plane, so it's going to be and the convention is going to remain same. What I said at the beginning of the question, this convention is going to be the same. So I'm going to write down Fe positive plus minus force of friction minus mg sine 2 degrees and equals to, now this time 1400 into A is not 0. A is going to be A is also going to be directed upwards, and it's not going to be 0 this time. So Fe is same. Basically, they are saying that given that the power, okay, power is the same. So power is the same. All right, power is the same. So if the power is same, if the power is same, if the power is same, the force of engine is also going to remain same. Why? Because if the power is not changing, it's 22,500, and this is the force of engine times the velocity initially is going to be 11.25. So what is going to be the force of engine? That's going to be 2000 Newton. So Fe is 2000 and minus 600, because the friction force is also not going to get, it's not changing. It's going to be minus 1400 times 10 times sine of 2 degrees. All right, equals to 1400 A. So now what are you going to get as A? 1400 times 10 times 1400 times 10 times sine of 2 degrees, 488 plus 600, 2000 minus answer, it's going to be 91911 equals to 1400 A. So A is going to be equal to what? 0.65 meter per second square. Is it clear to both of you or not?
Yes, sir.
Yes, sir.
Okay. Next, a particle Q of mass 0.2 kilograms is held in equilibrium by two light inextensible strings. Okay, string PQ and QR. P is a fixed point. Okay, and on a vertical wall, and R is a fixed point on horizontal floor. The angles which strings PQ and QR make with the horizontal are 60 and 30 degrees respectively. Find the tension in the two springs. Okay. So we are going to be looking at this particle Q. We're looking at this particle Q, and with respect to particle Q, tension is going to be directed away from it. And I'm going to take this as T1 and this is T2 because these are two different strings. This is not one string. These are two strings. So I'm taking tension as T1 in one of them and T2 in the other one. All right, and both of them are going to be directed away from the particle Q. And this is going to be mg. All right. Now it is held in equilibrium, which means no resultant force on Q. All right. Now what I'm going to do is I'm going to resolve T1. I'm going to resolve T1 into components. Like this. I'm going to resolve T2 into components like this. All right, this is going to be T1 cos of 30 degrees. This is going to be T1 sine of 30 degrees. This is going to be T2 cos of 60 degrees. This is going to be T2 sine of 60 degrees. Now I'm going to apply Newton's second law in the vertical and the horizontal direction. So in the horizontal direction, I'm going to set the convention right positive, left negative. For vertical direction, set convention up positive, downward negative. You may choose the other way. It's your choice. Now, in the horizontal direction, if you're going to apply Newton's second law, so towards right, I have T2 cos 60 minus T1 cos 30. All right. Is there any other force? No. Equal to 0. So it's going to be T2 cos 60. Cos 60 is half basically. It's going to be 0.5 T2. Equals to, what is cos 30? 0.86. 0.871. All right. And if I divide by 0.5, it's going to be 1.73. So T2 is going to be 1.73 T1. That's one equation. All right. Now in the vertical direction, what I have Mustafa, I have T2 sine 60 directed upward positive. And then I have minus T1 sine 30 directed downwards, and I have mg directed downwards. Equals to 0. Yeah. So I have 0.5 T1 minus 0.2 into 2. 0.2 into 2 will be 2. 0.2 into 10 will be 2. And this would be 0.87 T2. 0.87 T2. All right, so I have 0.87. Now I'm going to replace T2, 1.73 T1. All right, 0.87 into 1.73 T1 minus 0.5 T1 equals to 2. So it's going to be 0.87 multiplied by 1.73. Going to be 1.5. 1.5 T1 minus 0.5 T1 equals to 2. It's going to be T1 equals to 2 Newton. And T2 would be T2 would be 1.73 into 2. It's going to be 3.463. 3.5 Newton. Is it clear to both of you or not? All of you, all three of you.
Yes.
Yes, sir.
Yes.
All right. Question 4. The elevator moves vertically supported by a cable. The diagram shows a velocity time graph. An elevator moves vertically supported by a cable. The diagram shows a velocity time graph which models the motion of the elevator. The graph consists of 7 straight line segments. Okay. The elevator accelerates upwards from rest. Okay. We don't acceleration, then rest, deceleration, rest. Sorry, acceleration, constant velocity, deceleration, rest, and then acceleration in the other direction, then constant velocity, then deceleration. Okay. Find the acceleration of the elevator during the first 1.5 seconds. So it's going to be, I'm going to take the gradient because the gradient of velocity versus time graph gives you the acceleration. So the gradient of the first section is going to be 2 minus 0 over 1.5 minus 0. So how much is going to be? 2 divided by 1.5. 1.33 meter per second square. All right. Given that the elevator starts and finishes its journey on the ground floor, find V. Given that the elevator starts and finishes its journey on the ground floor, find V. Okay. So we are supposed to find out V. How we are gonna find out V? Omar, how are we gonna find out V? It's starting from the ground and it's finishing on the ground. Starting from the ground, finishing at the ground. All right. So that means the distance traveled is going to be equal. All right. The distance traveled while moving upwards and the distance traveled while moving downwards is going to be equal. All right. This is the distance. The area of the region under this section of the graph gives you the distance traveled while the elevator was moving upwards, and this is the area of this region under the graph will give you the distance traveled by the elevator while moving downwards, and these two are same. All right, so I'm gonna for part B, let me do it over here. Part B. So how would you calculate the distance? It's going to be it's basically trapezium. So like it's going to be from 1.5 to 6 is how much? It's 4.5, I reckon. Yeah. So 4.5 plus 7, half times 4.5 plus 7, all right, into 2 equals to this one. So it is half times how much is this? This is 5, and this is how much? This is 8.5. 5 plus 8.5 into V. All right. Now half and half is gonna get cancelled. All right, so we have then 11.5 into 2 is 23 equals to 13.5 into V. So V is going to be equal to what? 23 divided by 13.5. 1.7 meter per second. Is that clear to both of you, all of you, or not?
Yes, sir.
Yes, sir.
Amna is here. Amna is on.
Yes, sir.
Amna, can you just have you solved this paper before?
No, sir. I've not got this one yet.
You haven't solved this paper yet? Okay.
No,
I
sir.
want you to can you do me a favor? Just open up the marking scheme of this paper in another tab, and just kindly confirm me the answers. All right. The combined weight of the elevator and passengers on its upward journey is 1500 kilogram. Okay. The combined weight of the elevator and passengers on its upward journey. Assuming that there is no resistance to motion, find the tension in the elevator cable on its upward journey. Okay, so let me sketch an elevator for you people. This is the all right. This is the tension. It is upward journey. It's moving upward. All right. And what is the combined weight? 1500 mg, basically mg. Okay. Assuming that there's no resistance. There's no resistance to motion. There's no other force. You just have the tension acting on the elevator and the force of gravity. And find the tension in the cable upward journey when the elevator is okay. So I'm gonna set the convention upward as positive, downward as negative. I'm gonna apply Newton's second law. T plus minus mg equals to ma. All right, and okay. All right, and I don't know, T minus 1500 into 10 equals to M is 1500 into deceleration. All right, and what is our deceleration? You are supposed to get it from the graph. So assuming that there is no resistance to motion on its upward journey when it is decelerating. So this is this section of the graph represents the upward journey, and within this section you have this portion that is representing the deceleration of the elevator while it is moving upward. So how much is this? How much is this? So I'm going to calculate the gradient. So it's going to be 2 minus 0 over 7 minus 6. So it's going to be, no, it's going to be 0 minus 2. Sorry, 2 minus 0 over 6 minus 7. It's going to be minus 2 meter per second square. All right. So I'm going to put up over here minus 2. So it's going to be tension equals to minus 3000 plus it's going to be 15,000. So T is going to be equal to 12,000 Newton. Is it clear to both all of you or not?
Yes, sir.
Amna?
Yes, sir, this is the correct answer.
This one as well, 1.33 and 1.7.
Yes. 1.7 was which one?
Part A is 1.33, part B is 1.7. Is that correct as well?
Yes.
Okay, and what about question 3? It's 2 and 3.5. Is that correct as well?
Yes, it's 3.46.
Yeah, 3.47. Okay, let me write down 3.47. It was 3.47. I just wrote it down. Okay, 3.46.
46, yes.
Yeah, what about 2? Yeah, in 2 part B, 0.65.
0.65, yes.
Okay, and in 1 we have 0.1.
No, it's 1.
Yeah, sorry, it's 1. My mistake. 0.2 divided by 0.2 is 1. It's not 0.1. Okay. Okay. Good enough. Let's move on quickly. Question 5. The block of mass 5 kilogram is being pulled. Block of mass 5 kilogram is being pulled along a horizontal force of magnitude 6. Okay. Find the acceleration. Okay. So is there any it starts from rest and travels 2 meters in the first 5 seconds. All right, we'll be assuming that the acceleration is constant. All right, so we're going to be using s equals to ut plus half area square, and I'm taking towards right as positive, so displacement is going to be positive. So and u times t is going to be 0. Mustafa, the reason is because u is 0, so u times t is going to be 0. Half times 8 times 5 square. So it's going to be 4 divided by 25. It's going to be 0.16. A is going to be 0.16 meter per second square. All right, that's great. Then we have been told that the coefficient of friction between the block and the floor is this. So now I'm going to apply Newton's second law. I'm going to be resolving this force X into its components. All right, this component is going to be X cos of 30 because that's adjacent to angle. And this is opposite to the angle, so it's going to be X sine of 30 degrees. There's a force of friction as well. Force of friction is 0.4. And there's a force of gravity, and there's a normal reaction force. Normal reaction force is R, and this is 5 times this is mg. Now, I'm going to apply, because you have been given coefficient of friction. You haven't been given the value of the force of friction. We need to find out the value of force of friction, but for that, we'll be using the equation mu times R. And what R is, I don't know what R is. I need to apply Newton's second law in the vertical direction first. So I'm taking upward as positive. Downward is negative. So it's going to be R in the vertical direction. Vertical direction is going to be R plus minus mg equals to 0, because in the vertical direction we don't have any acceleration. So R is basically equal to mg, which is what? How much? 5 times 10. It's going to be 15 Newton. Now in the horizontal direction, I'm going to be applying the horizontal direction. In the horizontal direction, what forces I have? I have x. No. That's what I did mistake. People didn't. I have another force in the vertical direction, which is x sine of 30 degrees. Okay. So and that's acting upwards. So x sine of 30 degrees plus r minus mg, then equal to 0. So I'm gonna have mg, which is 50 newtons, 5 times 10, 50 minus 0.5x. I have this as one equation. Now in the horizontal direction, what forces do I have? X cos 30 towards right, positive, and force of friction as okay. That's force of friction equal to 0. Equals to acceleration is 0.6. So 5 times 0.16. So this is 0.87x minus mu r, which is mu is how 0.4 times r, and in 0.4 times r equals to 0.16 into 5 is going to be 0.8. So I'm going to replace r with 50 minus, all right, 0.87x minus 0.4 into 0.5, so 0.2 plus 0.2x and minus 50 into 0.4, 20 equals to 0.8, which is going to be 1.07x equals to 20.8 divided by 1.07, getting 9.4. This is going to be equal to 19.4 newtons. Is it clear or not? All of you?
Yes, sir.
Yes, sir.
Okay, the answers are correct, Ms. Amna.
Yes, sir. X is 19.5. Yes.
And we have left for 2 questions. Question 6. Okay, the block is now placed on a part of the floor where the coefficient of friction between the block and the floor has a different value. The block is now placed on a part of the floor where the coefficient of the friction between the block and floor has a different value. Okay. The value of x is changed to 25 and the block is now in limiting equilibrium. Find the value of the coefficient of friction. Okay. So the block is now placed on a part of the floor where the coefficient of friction, the coefficient of friction has changed. The value of x is, and the block is now in limiting equilibrium. That means limiting equilibrium means it does not have any, it is just about to move. It's not moving right now. It does not have any acceleration. Okay, na? Okay, so now I'm gonna, in the vertical direction, what you're gonna have? R minus, everything is gonna remain same. R plus x sine 30 minus mg. Okay. R plus x sine 30 minus mg equal to 0. R plus 25 sine 30. 25 sine 30 minus 5 into 10 equals to 0. So R is going to be 12.5 minus 50. 12.5 minus 50 is, 12.5 minus 50 is minus 37.5. So R is going to be equal to 37.5 Newton. Now in the horizontal direction, what equation do I have? Is x cos 30 minus force of friction equals to 0. Because it is in limiting equilibrium. So MA would be 0. It's 25 cos 30. 25 cos 30. How much it is? It's 21.7 minus mu times R is 7.5 equals to 0. So it's going to be mu is going to be equal to 21.7 divided by 37.5. 37.5 is going to be 0.58. Is that clear to all of you or not?
Sir, yes, sir.
Yes, sir.
Okay. Next question, quickly. A particle moves in a straight line. A particle moves in a straight line. It starts from rest. Particle moves in a straight line. It starts from rest from a fixed point O on the line. Its velocity at time t is this. Okay, find the displacement. How would you calculate the displacement? We will carry out. All right, we'll apply the integral. All right. Yeah, VDT is going to be equal to VDT. S is going to be equal to t square minus 8t to the power of 3 over 2 plus 10t. All right, and dt. S is going to be equal to t cube over 3 minus, it's going to be 8t 5/2 divided by 5/2 plus 5t square plus c. And we know that it had started from rest from a fixed point O. All right. So initially at time t equals to 0, the displacement is 0 because it has started from a fixed point O. So I'm going to keep 0. C is going to be equal to 0. So I have now my final equation for displacement as t cube over 3 minus is going to be 16 over to 16 over 5 t to the power of 5 over 2 t cube over 3 plus 5t square. All right, this is my final equation for S for the displacement. I'm supposed to find out this displacement when t equals to 1, so it's going to be 1 over 3 minus 16 over 5 plus 5. All right. So Amna is going to be 5 minus 48. 5 minus 48 minus 43 over 15 plus 5. And so S is going to be equal to what? 75 minus 43. It's 32 over 15. 2.13 meters. Is that clear or not, everyone?
Yes, sir.
Amna, is this the correct answer?
Yes, sir.
Okay. Show that the minimum velocity of the particle is -1. Minimum velocity. For minimum velocity, I need to first take the derivative of velocity. As I'm going to be finding out the acceleration, the derivative of velocity. And When the velocity is minimum, that means it's not changing anymore. So the acceleration is 0. That's how you calculate minimum maximum value. So minimum velocity means the value of rate of change of velocity is going to be 0. The value of acceleration is 0. So what is going to be dv over dt? That is going to be 2t minus 2t minus it's going to be what? 3 over 2 times 8 is going to be 12. 12t. 12t half plus 10. Plus 10. All right. Now it's going to be 2t minus 12t. Let me 2t minus 12t half plus 10 equal to 0. So let me factor out. 2 is going to be t minus 6t half plus 5 equal to 0. Now let me factor out. So it's going to be t minus 5t half minus t half plus 5 equal to 0. You may use the quadratic formula as well. It's your choice. You may take the substitution for t to the power of half as a, and then this would become a square, and this would become a, and then you may use the quadratic formula, solve for a, and then substitute for t to the power of half with the value of t. But I can see that I can factorize it easily, so I'm doing it directly. So it's going to be t to the power of half, t to the power of half minus 5 minus 1, t to the power of half minus 5 equal to 0. So t to the power of half minus 1, t to the power of half minus 5 equal to 0. So I have t to the power of half equals to 1, t to the power of half is equal to 5. So let's take the square on both, t equals to 1 and 25. So at 1 and 25, the velocity is minimum. So I'm going to substitute the value of t into the equation of velocity. It's going to be I'm going to be substituting 25. All right, so I'm going to be substituting 25. So 25 square minus 8, 25 to the power of 3 over 2 plus 10t plus 10 into 25. So v is going to be equal to 25. If I'm going to substitute 1, it's going to be 1 square minus 8 times 1 to the power of 3 over 2 plus 10 into 1. So from here, I'm going to get 1 plus 10, 11 minus 8, 3 meters per second. And with 25, I'm going to get what? 25 square is 620. This is 5 to the power of 3 is 125 into 8, 1000 plus 250. So 250 plus 625 minus 1000 going to be, that's 125 meters per second. Now, if you compare these two, so this is going to be minimum then. And this is going to be, of course, maximum then. All right. Because we need to state the minimum one. So this is going to be minimum, and we have shown it. They have asked us to show that, so we have shown it. So this must be the maximum. So we need to ignore this. All right. Is it clear to all of you or not?
Yes.
All right. Next question. All right. The next question is question 7. Two particles P and Q of masses 0.5 kilograms and m kilograms respectively are attached to the ends of a light inextensible string. So this is just one string. All right. So with respect to this particle, the tension is going to be away from it. with respect to this particle, the tension is going to be away from it. And because this is a string, this is just one string, so the tension is going to be same. The string passes over a fixed smooth pulley, which is attached to the top of two inclined planes. The particles are initially at rest. All right, the particles are initially at rest with the P. Okay, with P on a smooth plane inclined at 30 degrees to the horizontal. Okay, and Q on a plane inclined at 45 degrees to the horizontal. The string is taut. String is taut means the particles. String is taut. All right. The string is taut. String is taut, and the particles can move on lines of greatest slope of the two planes. Just a second. Just a second. All right, and then we have a force of magnitude 0.8 Newton is applied to P, acting down the plane, causing P to move down the plane. See diagram. It is given that M is 0.3 and that the plane on which Q rests is smooth. So like there is no friction on this plane. All right, and yeah. Okay, and the this plane and this plane, they both are smooth. So, all right, P on a smooth plane, Q on a smooth plane. Okay, so there's no friction force acting on each of these planes. Now, all right, so then we have, now I'm gonna apply Newton's second law. I'm gonna first consider each of these. Now I'm gonna apply equations, apply laws on each of these particles separately. Now this is gonna be mg. All right, and this is gonna be all right. This okay, this is R, and this is mg. This is gonna be 30 degrees. This is the adjacent components. It's gonna be mg cos of 30 degrees. It's gonna be mg sine of 30 degrees. All right, and I'm gonna do the same over here. All right, and let me resolve this force of gravity. Two components, perpendicular to the plane, parallel to the plane. All right, like this. This is 45 degrees. This component is going to be adjacent to, so it's going to be mg, mg again. It will be mg cos of 45 degrees, and it's going to be mg sine of 45 degrees. All right. P is moving down the plane, while Q is going to be moving up the plane. All right. Now let's apply Newton's second law on each of these particles. So I'm going to apply Newton's second law only along the plane. So along the plane, I have, I'm going to take down the plane as negative, up the plane as positive. So I'm going to have, for P, I have up the plane acting, on P, I have T acting up the plane, T plus minus 0.8 plus minus 5 sine of 30. All right, mg is 5.5. Half times 10 is going to be 5. So 5 sine of 30 degrees. All right, and then we have equals to ma. in fact 0.5a, sorry, minus 0.5a. Why? Because the acceleration of p is going to be downwards. So I'm going to take the negative of a minus 0.5a. All right. Now for q, now let me simplify it. So it's going to be t minus 0.8 minus 2.5 equals to minus 0.5a. And so I'm going to have then t equals to 3.3 minus 0.5a. All right. 3.3 minus 0.5. All right. This is the first equation. Now for Q, I have, have a look at this. So again, along the plane, I have T acting upwards. I have T acting upwards, and I have then mg sine 45 acting downwards. It's going to be mg is out. M is 0.3, so mg is going to be 3 sine of 45 degrees acting downwards equals to 0.3 times positive a. Why positive a? Because q is moving upwards, so the acceleration is going to be positive. Now I'm going to have t as equivalent to 3 times sine of 45. 3 times sine of 45 is going to be 2.12. 2.12 plus 0.13a. 0.3a, sorry. This is the second equation. When I equate these two equations, 3.3 minus 0.5a equals to 2.12 plus 0.3a. It's going to be 3.3, 1.18a, 1.18 equals to 0.8a. A is going to be equal to 1.47 meter per second square. And I'm going to substitute over here. So t is going to be how much? It's going to be 0.5. 0.3 minus answer, so it's going to be 2.56 newtons. So yeah, but the tension 2.56 newtons. All right, it was easy. Now we have this last part, and that is, it is given that the plane on which Q rests is rough, and that after each particle has moved a distance of 1 meter, their speed is 0.6 meter per second. The work done against friction in this part of the motion is half a joule. Use an energy method. They're particularly asking you to use an energy method. So I'm going to be using the Newton work energy theorem, that is net work done equals to change in kinetic energy. All right, and now it is given that the plane on which Q rests is rough, and after each particle has moved a distance of 1 meter, the speed is 0.6 meter per second. All right. Okay. So what? So there's a work done. So on Q. So on Q. On Q, let us discuss. Okay, on Q, let me apply this work energy theorem, and let me see that what are the forces acting on the. So we have T is work done by T. All right. So okay, so Q is moving upwards, and T is directed upwards. So the work done by T is going to be positive, and it's going to be T times 1, because you have traveled a distance of 1 meter, so T times 1. And then I'm going to add up the work done by this component of work done by gravity. The other force is the force of gravity. All right. And I'm not going to consider the component. Yeah, you may just take the component, this component that is acting along the plane, which is mg sine of 45. And how much does this component of force of gravity does work? And that is minus minus m minus mg sine of 45 times 1. That's the work done by the component of gravity along the plane on Q. And is there any other force? No. So that is equivalent to MA. And there's gonna be a work done by, as Q is gonna move upwards. So now the plane is taken to be as rough. So there's gonna be force of friction as well acting on Q. And so the work done by force of friction on Q over a distance of 1 meter is given as 0.5 joules. So, and that's going to be negative as well. Why negative? Because the force of friction and the displacement, they are opposite in direction. So the work done is going to be taken as negative. And same goes for this component of gravity. It's acting downwards while the displacement upwards. So yeah, equals to M, and A is not known yet. Okay. So I'm gonna have T minus sine 45 is times 10 is going to be 7.07 minus 7.07 m minus 0.5 equals to ma. All right. Now I'm going to apply now on Q. I'm going to apply on P now. All right. I'm going to apply on P. I'm going to apply on P now. So on P, and okay, now this is not equals to this is going to be equal to this equal to change in kinetic energy. So half m. They have started from rest. Yeah, they're initially at rest. So half mv square minus u square is going to be equal to 0. And the speed, and which is half times m into v square, which is 0.6 square. All right. So this is going to be how much? It's 0.6 times 0.6 divided by 2 is going to be 0.18 m. 0.18 m plus 7.07, 7.25 m. T minus 0.5 equals to T will be equivalent to 7.25 m plus 0.5. All right, so that is going to be one equation. Now, as I'm going to apply on P as well. Now, on P again, the work done by tension is going to be positive, because no, the work done on P by tension is going to be negative, because P is moving downwards and tension is directed upwards. So the work done by tension on P is going to be negative. So minus T times 1. All right. And then it is moving downwards, and this component of force of gravity is downwards. So the work done by this component of gravity is going to be positive. So mg sine of 30 times 1. Both of the particles are moving distance. And like there's no friction force acting on P, because the surface of P, the surface on which the P is placed is like taken as smooth, so no friction force, so no work done by friction, equals to half m u square is 0. What about V? It's 0.6 square. All right, V square. And so it's going to be minus T plus M is how much? It's 0.5. Now there's a work done by this force as well, 0.8 Newton. I just forgot to include this. It's going to be positive as well because this force on P is directed downwards and the displacement is also downwards. So the work done by the force of 0.8 Newton is on a positive as well. So it's going to be 0.8 times 1. All right. So minus T plus 5, 2.5, 0.5 into 10 is 2, 0.5 into 10 is 5 into 30 is 2.5 plus 0.8 equals to half times 0.5 times 0.6 square. So okay, T is coming out to be then how much? 0.6 square into 0.5 divided by 2 is going to be 0.09. 2.5 plus 0.8 minus 0.09 is 3.21. All right, we're going to substitute over here T, and I'm going to get then 3.21 equals to 7.25 M plus 0.5. So minus 0.5 divided by 7.25 going to be 0.37. M is coming out to be 0.37 kilograms. All right, let's check it out. Yeah, 0.374, 0.374, 0.37 kilograms. So that's it. We're done with the question. We're done with the paper, in fact. And we'll meet in the next class to do another paper, inshallah. May June 2021 and paper 41, inshallah. All right. Take care. Allah Hafiz.